All right, properties of the graphs of sine and cosine. There's quite a few pages of this. We're going to go through and talk about all the different properties. So you may have noticed in the previous video that sine and cosine, they make this little wavy motion, and we could have kept going forever, and it actually makes this little wavy motion forever in either direction, and it repeats itself. And if a function repeats itself, we call it a periodic function. So they repeat themselves forever. With periodic functions, they have what's known as a period, and that's the amount of time it takes for the cycle to complete. So from here to here, if you look at that, that's a complete cycle, right? Repeats itself over here. This guy right here, duplicate. So that's the amount of time it takes before it repeats itself, right? I could just continue doing that. And we call that one period. So the amount of time it takes to go from the same position, from a position in one cycle to that same position in the next cycle. That is a period. So you'll notice for sine and cosine, it repeats itself after, oh, that turned into a line. That's fine. It repeats itself after 2 pi. So this shape right here, the same as this shape here. Same over here. Pshoom, pshoom. So the period for just your basic sine and cosine functions is 2 pi. Then there's the amplitude of the function. So with sine and cosine, they make this little wavy motion, right? The amplitude, you notice that it kind of oscillates around like a line. It goes back and forth, up and down, right, around a line. That line we call the midline, but more importantly for amplitude, the distance between the midline and the peak, or the midline and the bottom, they're the same distance. We call that the amplitude. So if the amplitude is really big, it will be really tall, and if the amplitude is small, it'll make little small waves instead. For sine and cosine, the amplitude, so you can tell like the midline is right here, it's at y equals 0. This is right here is the amplitude, and that distance is 1. So the amplitude for just the basic sine and cosine functions is 1. As a note, you can also think of the amplitude as half the distance from the top to the bottom. So if you know that the distance from the top to the bottom, amplitude is half of that. From peak to valley is how I'll put it. So if you know this total distance, half of it would be the amplitude. All right, vertical shift is exactly what it sounds like. It's the amount that a graph is shifted up or down. So if you remember in pre-calculus, you probably did a lot of transformations with shifting up and down, shifting left and right. Vertical shifts are the same type of shift as you saw in your pre-calculus course. Amplitude, on the other hand, this is the same concept as horizontal stretching or horizontal compressions. And periods are not a thing you talk about in pre-calc 1, really. That's more of a pre-calc 2 concept. Boop, where are we? Vertical shifts. So a vertical shift is just boop, the graph shifts itself upwards or downwards. It just shifts away from where it was oscillating. For sine and cosine, they oscillate around the line y equals 0. There is no vertical shift. They are the original function. So the vertical shift for the original function is 0. The line that the function oscillates around, the one that goes directly down the middle, we call it the midline. All right, so the midline is the same value as the vertical shift. And that's important, the midline and the cosine graph, it's always the same. Maybe I'll just write it here. Midline is equal to the vertical shift. So again, for sine and cosine, just the basic functions, it's 0. Phase shift. In pre-calc 1, we talked about this as a horizontal shift. We call it a phase shift for trigonometry. But a phase shift is going to be taking, let's see, taking a function and shifting it left or right. So if you take this guy, instead of starting him here, boop, you shifted him over, that would be a phase shift. For our original functions, sine and cosine, just regular sine and cosine, there is no phase shift, it just starts at 0. And then finally, this last page from this section, there's a lot of warm up here, are key points. Really, these are like key x values, but key points. You'll notice that when we graphed in the previous video, we graphed sine and cosine, and we said, so this is one period right here. You'll notice that there's specific points that I plotted. I plotted the places where it intersected the x-axis, and I plot the top and the bottom points. And I don't bother plotting anything else because I don't really need to. And you can see it over here as well, right? Where it intersects the x-axis, the top, and the bottom. And those are the places that I plot. And for any sine or cosine graph, that's what you're going to be doing. So for sine, it starts at the midline, and then it has 3 x-axis intercepts. So those all get plotted. 1 peak, 1 valley. Cosine looks like this. It has 2 x-intercepts, 1 valley, 2 peaks. And this is just for our basic sine of x, cosine of x functions. You plot those points. This is one period, a quarter of the way through. So you just keep on moving. There should be a point at the beginning, a point at the end, and a point at every quarter. So this is a quarter of the way through, 2 quarters of the way through, 3 quarters of the way through, all the way through. Those are the only points you need to plot. And you'll see that in the next video. For the shape, so here's a hot tip. Cosine looks like a C, and sine looks like a bad S, right? Not a great S, but a bad S. But cosine makes the C shape over one period. Sine makes the S shape over one period. Cosine, it's either going to start at its highest point or its lowest point. And that's all going to depend on what number comes in front of cosine. So if the number in front of cosine is positive, it will start at the top and then go down. If the number in front of cosine is negative, it will start at the bottom and go up. So this was when you talked about it in your pre-calc 1 class, you talked about reflections over the x-axis. This is a reflection over the x-axis. So examples of functions where where cosine starts at the top, it could be like 2 cosine x, or y equals 9/5 cosine x. Anything where that number out in front is positive. For the negative version, you'd have something like, maybe I'll move it over here. There's just no room. Down here is where I'll move it. Didn't leave enough room on this page. Something like -3 cosine x, or -5/12 cosine x. The key thing is that there is a negative out front. If it's a negative out front, you start at the bottom. Just kind of shrink it down, put it right there. There it goes. All right, for sine will always start at the midline, and then it goes up first if the coefficient out front is positive, and it goes down first if the coefficient is negative. So again, it's like the same idea. So if you had something like 3 sine x, that would go up first because 3 is positive. If you had 12 sine x, anything where there's just a positive number out front and it's sine x, that'll go up first. For the negative, it'd be like -2 sine x, or y equals -7/3 sine x. Anything where there's a negative out front, it'll start at the midline and then go down. So these are all things you're going to need to memorize. You're going to need to memorize the way that these graphs are shaped, and the different properties of these graphs. So we're going to go through transforming some of these graphs, stretching them, phase shifting them, vertical, up, down, left, right. I really like this section, actually. I think it's a lot of fun. It's a lot different than the way we talk about graph transformations in a pre-calc 1 class. I think it's a lot more fun as it relates to trigonometry. So we'll get into that all, and the different types of problems you can do in the next video. All right, see you then. Bye.